At 0530 local time, a Russian Bayern M corvette, loaded with 8-caliber cruise missiles, was gearing up in the Sea of Azov to unleash hell on Ukrainian cities. The mission had been eerily quiet so far, but that was about to change in seconds. Unbeknownst to the Russian sailors, 7 Ukrainian drones were closing in, hunting them down. The lead Rebecca screamed forward at 400 km/h as Russian checkpoint guns roared to life. Tracers lit up the dawn sky. Each 23mm shell could shred a drone into scattered debris. And that's when the real chaos kicked in. The checkpoint gunner couldn't see the drones, but he could hear their whine. He fired at the sound, walking rounds toward that telltale hum of motors. The lead Rebecca jinked hard left. 23mm shells exploded around it, each one a heartbeat away from obliteration. The drone pushed to its limit, 432 km/h, screaming past before the gun could track it. But the damage was done. The gunfire alerted every Russian post within 10 kilometers. Telegram messages spread faster than military radios. The element of surprise? Gone. The operator's screen suddenly filled with static, power lines, invisible until the last second. The drone yanked up, clearing 110,000 volts by just 2 meters. Instruments went haywire, compass spinning, video feed flickering, flying blind for 3 agonizing seconds. Then a radio tower loomed from the dark. The operator banked hard left, missing the guy wires by inches. Behind the lead Rebecca, 2 more drones trailed, 30 seconds apart, slipping through the chaos. These were the Spear, built to blind the ship's radar defenses. They had to make it. For Bober drones took the northern route, slower at 200 km/h but packing heavier warheads. These were the Hammer, ready to strike once the Rebecca cleared the path. But those telegram warnings had reached the next checkpoint. A Repellent 1 jammer was waiting, blasting 400 watts of electromagnetic noise across control frequencies. The lead Bober's screen went black, signal lost. The Ukrainians were ready, though. Pre-programmed waypoints kicked in. The drone switched to autonomous mode, navigating by accelerometer and optical landmarks, slicing through the electromagnetic storm. 3 minutes later, the video feed flickered back. The Bober was dead on course. But ahead, a BTR-82 blocked the highway, its machine gun spitting fire in predetermined patterns. The operator dove into an industrial zone, using buildings to break line of sight. But those buildings hid Russian soldiers. Hearing drone motors, they swarmed out like ants from a kicked nest. The drone held 10 meters altitude, exploiting the Earth's curvature to create radar shadows. A hilltop radar that sees 50 kilometers at altitude could only spot 12 kilometers when you're skimming the ground. Physics was their shield against the BTR. The drones threaded invisible corridors of safety as soldiers fired at sounds and glimpses. But statistics don't lie. Concentrated fire from a coordinated squad finally connected. The third Rebecca spiraled into a parking lot, its warhead detonating on impact. 2 Bobers and 2 Rebeccas left, they couldn't lose another. Then the lead Rebecca crested the final ridge. The operator's screen showed something impossible. The mission briefing was dead wrong. In 4 seconds, he'd have to make a call that could save the mission, or doom every drone. The Panzer launched 6 missiles at once. These weren't standard surface-to-air missiles but Panzer M anti-drone interceptors, built after commercial quadcopters humiliated Russian defenses. Each 12 kilograms missile carried 200 tungsten spheres and a fragmentation warhead, designed to shred small UAVs in a donut-shaped blast. The spheres would fan out at 1,800 meters per second, forming a 10-meter-wide lethal cloud. The Panzer operator used ladder tactics, launching missiles at staggered altitudes, 50 meters, 30, then 10, forcing the drone to fly through at least 1 kill zone. The fire control system calculated intercept points, boxing the drone in a 3D death trap. Each missile's proximity fuse pulsed radio waves, waiting for enough metal to trigger. But the Rebecca's operator had studied Panzer engagements inside out. He knew the missiles had a 1.2-second arming delay to protect the launcher. At 432 kilometers per hour, the drone covered 144 meters in that time. Spotting the missile launch flares, he pushed the stick forward, diving straight at the Panzer. The missiles streaked overhead, their fuses still safe, unable to detonate as the drone passed meters away. By the time they armed, the Rebecca was below them, turning the launcher's own safety protocols into a shield. The operator leveled out at 5 meters and locked onto the Podlet K1 radar, the system feeding targeting data to every Russian launcher within 200 kilometers. The Panzer's twin 30mm cannons roared, cycling at 5,000 rounds per minute. The gunner tried boxing tactics, firing into rectangular zones where the drone should be. But the fire control needed 1.5 seconds to calculate, 0.5 seconds for servos to aim, and 1.5 seconds for rounds to travel 2 kilometers, 3.5 seconds total lag. The drone operator changed course every 2 seconds, making the gunner chase a ghost. The Rebecca punched through and slammed into the radar antenna. Its shaped charge triggered the Monroe effect, a copper cone crushed into a hypersonic jet, punching through armor like a needle through paper at 7,000 meters per second. The jet tore through the antenna, processing units, operator stations, and out the back, dispersing into copper spray. The second Rebecca targeted the P-18 Spoon Rest early warning radar. The Panzer switched to thermal imaging, but Dawn's temperature inversion, cool air trapped under warm, created thermal shimmer and false signatures. The drone's electric motors barely generated 10 degrees Celsius above ambient, blending into the morning sea's residual heat. It vanished entirely over cooler land patches. The thermal imager, built for 600 degrees Celsius jet engines, couldn't lock onto such a faint differential. The Panzer gunner fired in desperation, using a spiral pattern from the drone's last position. This water hose tactic might work against sluggish helicopters, but the drone pivoted 90 degrees in half a second. 5,000 rounds fired, 0 hits. The Rebecca struck the P-18 dead center, wiping out 200 kilometers of radar coverage instantly. With both radars gone, the corvette 4 kilometers offshore was blind, its early warning network shredded. Without the Podlet and P-18, the ship's radar could only see 40 kilometers, less than 2 minutes warning. The defensive shield was gone. The corvette, poised to launch missiles at Ukraine, was now exposed. Its radar picked up the drones at 4 kilometers, ghost contacts flickering with the waves. The ship faced an impossible task, distinguishing 3-meter altitude drones from 2-meter waves, both creating similar radar returns. Doppler shifts, meant to separate moving targets, failed as the drones varied speeds between 80 and 120 knots. The clutter rejection algorithm, designed for sea spray, started filtering out real threats. Every third sweep, the drones vanished from the screen, dismissed as false returns. The AK-630M2 duet system spun up with a mechanical whine, unleashing 10,000 rounds per minute from twin 30mm cannons. Its Kalman filtering algorithms tried to predict the drone's paths, blending past positions with current data. But the operator's random inputs every 2 seconds threw off the math. Designed for 3,000 kilograms P-270 Moskit missiles on predictable paths, the system was useless against 150 kilograms drones zigzagging wildly. It was like swinging a sledgehammer at a hummingbird. The computer needed 3.5 seconds for a firing solution, the drones changed course every 2. The math never lined up. The corvette fired its PK-10 decoy system, launching chaff clouds, aluminum strips cut to disrupt radar. False targets bloomed across every screen within 50 kilometers. Against radar-guided missiles, it'd be chaos. Against human-guided drones with cameras? Just sparkles in the sunrise. The operators ignored the light show, keeping visual lock on the ship. The TK-25E electronic countermeasures blasted 200 watts across 20 MHz to 40 GHz, enough to kill normal radio links. But the Ukrainian drones used frequency-hopping spread spectrum, jumping 128 channels per second in a pattern only their operators knew. Jamming caused pixelation, dropping the feed from 1080p to 480p, but the link held. The corvette's captain ordered evasive S-turns at max speed, but a 949-ton ship takes 15 seconds to shift 30 degrees. The drone? 50 milliseconds. The Rebecca operator timed his approach for the steady moment between turns. At 500 meters, he switched to manual, the radar mast filling his screen, 6 meters of critical electronics. The duet cannons couldn't depress below -5 degrees. At 200 meters and 3 meters altitude, the drone was untouchable. Sailors with PKM machine guns fired from the deck, but the drone crossed their view in 0.8 seconds. Human eyes need 0.2 seconds to focus, 0.3 to track, and 2 to aim. By then, the drone was 100 meters away. They were shooting at retinal afterimages. The lead bobber aimed for the ship's mast, its shaped charge primed to shred the radar arrays. The captain screamed for an emergency launch, trying to fire the caliber missiles before the ship was crippled. But the launch needed 2 minutes for gyroscope alignment, target validation, and missile warming. The bobbers were 30 seconds out. The first bobber slammed into the mast. Instantly, every radar, comm suite, and data link went dark. The ship couldn't fire its missiles, a sitting duck. The second bobber dove at the port side at a 30 degrees angle, targeting the junction between frames 44 and 52, where the missile magazine sat behind 15 millimeters of steel. A perfect hit could detonate the caliber missiles in their cells, turning the ship into a fireball. At 100 meters, the operator tweaked for the ship's 8-knot drift and 3 degrees list. The shaped charge needed a 90 degrees hit for max penetration, too shallow, it'd deflect, too steep, it'd waste energy. The operator had trained for this 500 times in sims, but reality threw in shaking hands, see spray on the lens, and the weight of knowing a miss meant more Ukrainian cities bombarded. The bobber hit the magazine's forward bulkhead. Its copper cone, compressed by explosives, triggered the Monroe effect, a molten jet at 7,000 meters per second. The 15mm steel was like tissue paper. The jet sprayed molten copper across ammo and missile components. The second bobber struck the missile handling gear, hydraulic pumps, fuel lines, and electronics that made missiles smart. The blast ruptured 3 systems at once. Hydraulic fluid at 3,000 psi sprayed across electrical panels, sparking arc fires. Coolant lines burst, releasing toxic hydrazine derivatives. Most critically, warhead safety interlocks broke, leaving 8 caliber missiles armed but useless. The corvette didn't sink. It limped into port 12 hours later, superstructure charred, hull breached, smoke rising from internal fires. Repairs would take 18 months, if Russia could even get parts through sanctions. The 8 caliber missiles meant for Ukrainian cities never launched. Ukrainian operators, 300 kilometers away in bunkers, had crippled a $500 million warship with drones built from Alibaba parts. Bye for now.